Welcome to Dang Laboratory at the University of Fukui. Our research group is dedicated to creating energy technologies that harmonize the environmental sustainability and human comfort. We take into consideration long-term societal changes and environmental sustainability, focusing on the comprehensive research towards achieving high energy efficiency, decarbonization, and smart use of energy. Our research fields span across energy engineering, environmental studies, heat transfer engineering, and ergonomics. We conduct research from a broad perspective and from multiple angles. In the field of energy studies, our first focus is on the research and development of high-concentration photovoltaic thermal systems. By concentrating sunlight over 1,000 times, we can simultaneously achieve efficient power generation and high-temperature heat recovery. From the current 12% power generation efficiency of solar power, we have developed a system that increases overall energy use efficiency by 70%. Secondly, we are working on the efficient cooling and energy recovery of data centers. With the increasing centralization of IT equipment in data centers due to the progress of cloud computing, the amount of information handled in data centers is growing exponentially. We are developing and evaluating phase change cooling servers that directly cool CPUs and memory. Thirdly, we are developing a thermal management system for electric vehicles. In order to make electric vehicles more energy efficient, we are developing a system that comprehensively manages heat flow in the battery system, powertrain, and cabin air conditioning. In addition, we are working on the development of integrated air conditioning, humidity control, and hot water supply systems, and the development of optical fiber-type temperature and humidity sensors. Refrigerants used in refrigeration and air conditioning equipment have global warming potential values ranging from hundreds to thousands, and the transition to refrigerants with lower GWP, which are more environmentally friendly, is stipulated in international treaties. It is an urgent task to find and evaluate low GWP refrigerants suitable for each application in order to achieve Japan's greenhouse gas reduction targets and form a sustainable society. We are working on the development of low GWP refrigerants, the evaluation of their thermal properties and heat transfer performance, the development of system performance, and the standardization of refrigerant charge amounts at the international level. In particular, we are conducting experimental studies and molecular simulations on the safety evaluation during pump-down of air conditioning equipment, thermal decomposition characteristics of refrigerants, self-decomposition reaction characteristics, and decomposition reactions on catalytic metal surfaces, as low GWP refrigerants often raise safety concerns during use. Heat transfer engineering is a field of study that deals with heat transfer phenomena from an engineering perspective. Our lab is committed to the development of high-performance heat transfer equipment and the elucidation of heat transfer mechanisms. For example, we are developing a micro heat exchanger using diffusion bonding technology and studying its system configuration, as well as conducting experimental measurements of boiling heat transfer inside heat transfer tubes and supersonic flow accompanied by shock waves. Furthermore, we are measuring pool boiling heat transfer characteristics with a high-speed camera and developing high-performance heat transfer surfaces. We are also conducting experimental measurements of the velocity field of unfrozen water during droplet freezing using PIV technology, studying the effects of dissolved oxygen on bubble formation during droplet freezing, and visualizing and elucidating the mechanism of droplet coalescence and jumping characteristics on superhydrophilic surfaces. Moreover, we are developing temperature-responsive surfaces whose wettability changes with temperature and elucidating their mechanism and application to heat transfer equipment. We are also conducting experimental research on the change in the thickness of the liquid film formed during evaporation inside small-size channels. Ergonomics in our lab focuses on improving human comfort and enhancing and maintaining thermoregulatory functions. We develop and evaluate non-invasive thermal sensation measurement methods for occupants using machine learning techniques. Furthermore, we propose thermal environmental control methods and develop human thermal physiology models for the elderly and frail. We utilize a camera installed in the air conditioner to continuously detect the body temperature of the occupants, and use this data as a basis for annual health management. In addition, we develop a system to send alerts for health abnormalities by building a 24-hour body temperature monitoring system through the collaboration of air conditioners and wearable devices such as smartwatches. The temperature range of our research covers from superconductivity and cold heat generation below -100 degrees, refrigeration and air conditioning equipment near room temperature, and solar power and nuclear power generation at the level of several hundred degrees. Specifically, we focus on 1. Reducing losses through the development of high-performance heat transfer equipment. 2. Reducing environmental impact through the use of low GWP refrigerants. 3. Developing new energy devices. 4. Understanding and effectively using the mechanism of phase change heat transfer and supercritical fluid heat transfer. 5. Developing human thermal physiology models and proposing thermal environment control methods. In terms of our research methods, we first construct a theoretical model of the research subject, then concretize the characteristics using numerical analysis methods. Then we validate our theoretical model using methods such as experimentation. In the case of complex research subjects, we simultaneously extract characteristics using machine learning methods. The supervising professors have been awarded the academic prize from the Japan Refrigeration and Air Conditioning Industry Association 6 times, and the Asian Academic Prize from the Japan Refrigeration and Air Conditioning Industry Association and the Korean Society of Heating, Refrigerating, and Air Conditioning Engineers. They have published over 130 papers with more than 4,600 citations. They have also presented at over 120 international conferences and have delivered over 20 invited lectures at research institutions both in Japan and abroad. He was also selected as world's top 2% scientist of 2021 year. Our lab is equipped with state-of-the-art research facilities. We provide an environment where students can freely design and manufacture based on their ideas and verify their own concepts. We welcome students who are interested in environmental issues, are not bound by conventional frameworks, and have the ambition to explore new possibilities through their imagination.